Morning, Ramona.
All right, guys, gentlemen, ladies, thank you for your attendance this morning. We're going to have a brief review today on industrial ergonomics. Again, this isn't anything new. We've all had this training in the past, and it applies in every walk of our life, professionally, personally. It's a good reminder, both for the shop, the field, and for the office employees. So what is ergonomics? Ergonomics is the process of reducing worker injury through effective workplace design, such as decreasing the amount of bending or reaching for items, or using equipment to reduce the strain on the human body. Today's review will remind us how to use ergonomics in an industrial setting to reduce injury. Employees will learn how to identify ergonomic risk factors, potential injuries, and methods to minimize or eliminate ergonomic hazards. So in a nutshell, that's basically what we're going to review today. And if you will all, again, as usual, mute your phone so we don't have any background noise. We'll complete our video today and we'll go to our tech topic with Rob Coombs, who'll be presenting on behalf of Adam Carter. At that point, we'll go into a roll call and or roundtable if you have any questions or discussion topics. So with that, gentlemen, we'll go ahead and I will start this morning's video.
Industrial ergonomics. Hey, Jill, what on earth is industrial ergonomics? Well, Jim, ergonomics is the science of equipment design. Its intent is to maximize productivity by reducing operator fatigue and discomfort. I'm sure from time to time you've worked on equipment that was positioned above your head on the ground or too far out of your reach. And if the job took any time at all, you've most likely dealt with the soreness, aches, and pains from working in those awkward positions. The pain could have been prevented by positioning the task at a comfortable working level, and that's the science of industrial ergonomics. The company is dedicated to providing you with a comfortable and safe workplace. After all, a comfortable and happy workforce is a more productive workforce, and proper ergonomics is part of that effort. When looking at ergonomic risk factors, we look at two groups of characteristics. One is the physical characteristics of the job, and the other is the environmental characteristics of the job. The physical characteristics are posture, force, workstation design, repetition, duration, recovery time, heavy exertion, and partial vibration. The environmental characteristics include cold stress, heat stress, lighting, noise, and whole body vibration. Now, I'm not going to detail out all the risk factors, but it's important to be aware of all of them and how they can contribute to the overall ergonomic risks of the job. The three ergonomic risk factors of doing your job are posture, force, and workstation arrangement. Posture is the position the body is in while performing work activities, and it's been proven that awkward posture can be responsible for some ergonomic injuries. The second factor, force, is the toll of any physical exertion on internal body tissues, or the physical impact an object has with the body. Generally, the greater the force, the greater the degree of risk. Industrial ergonomic risks also deal with your workstation and what interaction is required between you and that station to accomplish your daily tasks. To clarify, a workstation can be small and compact, or it can be a larger, multi-spaced area, depending on the job requirements. If the workstation is arranged without ergonomic risks in mind, it could lead to workplace injuries. Good ergonomic arrangement allows our bodies to be in a natural or neutral position while working, thus allowing the greatest comfort and the least amount of stress on the body. When assessing the work and determining the degree of potential ergonomic risk, the company also factors in any repetitive movement, its duration, and its recovery time. The type of repetition is considered along with the number of times it's repeated. For instance, the swinging of a hammer 60 times per minute versus 12 times per minute. The more often the repetition is required to perform the task, the increased chance of ergonomic injury. Also, the longer the repetition must be performed increases the chance of an ergonomic injury. Recovery time is also important to consider. Recovery time includes breaks, time between shifts or time spent at other tasks that do not require the repetitive motion. The longer the recovery time, the less likely an ergonomic injury will occur. In an effort to reduce the risk of ergonomic injuries in the workplace, the company assesses individual work sites and makes necessary adjustments to workstation design. This not only can prevent injury, but it can also enhance productivity and improve the quality of our work life. Because ergonomics involves the worker interacting with their workstation, different adjustments and designs may be necessary from station to station. For instance, a 6'2" 200-pound male worker will have different workstation requirements than a 5'5" 120-pound female worker because the range of movements and length of reach are different. Therefore, the comfortable height for a workstation would differ for the two. The key to an ergonomically designed workstation is keeping the body in the natural or neutral positions as much as possible. In other words, it is best to keep the body aligned as it was designed and intended to be, not positioned awkwardly. This will cause unneeded muscular or skeletal stress. The approaches taken by people specializing in workstation arrangement and design can be very complex. For example, they consider the ideal standing position, which is with the back straight, the neck and head at a comfortable natural position, and the elbows at 90-degree angles. This may not be constantly obtainable, but it is what workstation designers strive toward. The injuries caused by poor ergonomic workstation arrangements are referred to as musculoskeletal disorders. These are injuries and illnesses that can occur in the muscles, tendons, ligaments, or bones. They include back pulls and strains and carpal tunnel syndrome of the wrist. They also include neck, leg, knee, shoulder, and arm injuries from excessive force and vibration. All these problems can occur if the arrangement of the workstation requires awkward or unnatural body positioning. But of course, not all musculoskeletal disorders are work-related. These disorders can and do occur outside the workplace. As stated by the Occupational Safety and Health Administration, or OSHA, back injuries are the nation's #1 workplace safety problem. More than 1 million workers suffer back injuries each year, and these injuries account for 1 in every 5 workplace injury or illness. Back injuries commonly occur from incorrect lifting. There's a right way and a wrong way to lift, a safe way and a dangerous way. Back injuries can be a very painful, debilitating injury. Depending upon the extent, a back injury could lay you up for days, weeks, or even longer. So why isn't lifting done properly each and every time? Because the wrong way, in fact, is the easier way, and bad habits are hard to break. Let me ask you, Jim, do the words carpal tunnel mean anything to you?
Yeah, didn't we drive through that tunnel in Colorado last year?
No, Jim. Carpal tunnel syndrome is the result of the wrist being bent and held at an angle for long periods of time, or having to repetitively bend the wrist to accomplish a task. It usually develops slowly over an extended amount of time. Here, let's look at what happens in the wrist to cause carpal tunnel syndrome. There's a group of nerves running from our hands up through our arms. This group of nerves is contained or housed in a sheath of tissue resembling a tunnel. When the wrist bends, it applies pressure to the tunnel and the nerves it contains. This is usually not a problem in everyday life, but when bending the wrist over and over, day in and day out, the tunnel can become irritated, swollen, and in turn put pressure on the nerves themselves. Carpal tunnel syndrome can be very painful, and in some cases require therapy or surgery to correct. Pain and discomfort can also be another problem caused by poor ergonomic conditions. When the task being performed requires you to bend your head back, looking upward, discomfort can develop in a very short period of time. There was a reason why Michelangelo laid on his back on a complex scaffolding system to paint the ceiling of the Sistine Chapel. On the other extreme, having to bend your head downward for extended periods of time can also cause a lot of discomfort. Also, the task should not require the worker to move their head repetitively from side to side. In all of these cases, the neck is out of its natural position. Leg and knee strain can be caused by a variety of ergonomic problems. A task requiring you to stay crouched or kneel down can eventually cause stress and strain to the knee and its ligaments, not to mention the constant struggle to keep your balance in those positions. Leg and knee strain can also result from having to stand still in one position for extended periods of time. Some steps that can be taken to reduce the stress of a standing workstation include having good posture while standing, standing on a cushioned floor mat, and taking breaks to sit or just walk around. A repetitive twisting motion at the waist can also cause stress and strain. The workstation needs to be studied to determine if these potential injuries meet many OSHA requirements. The most acceptable method to correct ergonomic problems in the workplace is to use engineering controls, administrative controls, or personal protective equipment to deal with the issue. Fortunately, many products have been designed and engineered to help reduce or eliminate ergonomic stress. These include equipment designed to eliminate awkward body positioning, repetitive motions, vibrations, and the need for excessive force. As an example, let's take material handling and the potential engineering controls that reduce ergonomic stress. We all know the need for moving materials in the workplace is inevitable, but using mechanical means instead of the body's physical means to move that material is the best way to prevent injuries. So dollies, forklifts, and conveyor belts are all types of engineering controls. When engineering controls are not available or feasible to implement in a particular workstation, administrative controls are then considered. They would include steps like reducing the duration of the hazard through worker rotation, requirements to have assistance with lifting, or additional ergonomic training. Also, limiting overtime work and increasing break frequency or duration are administrative controls. When these controls are in place, they must be followed and implemented correctly. If they are not carried out properly by the worker, the protection against ergonomic injury will be greatly diminished. There are several steps in lifting an object the right way. First, position yourself close and directly in front of the object you are lifting. Do not reach out or over something to lift any object. Make sure you have secure footing, bend your knees not to your waist, and keep your back straight. Get a good grip with both hands on the object. Lift it as close to your body as possible in a slow, continuous motion back up to a standing position. In time, this new lifting method will become second nature. Personal protective equipment, or PPE, can also be used as an ergonomic control. PPE is made for the user to wear in order to reduce or eliminate a workplace hazard. But because it is easier to change and redesign inanimate objects than it is to change or redesign the human body, engineering or administrative controls are usually a better choice for ergonomic hazards. PPE should only be used as a last line of defense when dealing with ergonomic hazards. Now that you have a better understanding of what ergonomic injuries are and why they can occur, you can keep an eye out for potential ergonomic hazards. If you experience numbness, musculoskeletal aches or pains during or at the end of the workday, report it to your supervisor. Clearly, there are advantages to reporting potential ergonomic problems. It gives you a way to provide input about your job, correct any existing problems, prevent possible future injury, and make the workplace less stressful and more productive. Now it should be clear that the arrangement and design of workstations is critical in the prevention of ergonomic injuries and illnesses. Whether the injuries were a quick onset or the result of a long repetitive problem, they occur because one or more of the following conditions exist. The worker does not fit the workstation well enough. The tasks required to accomplish the job are beyond the physical limits of the worker, or the worker is not using the ergonomically designed tools or other provisions correctly. Think about your workstation. Can you identify any potential ergonomic problems? Can you identify any ergonomic solutions that may have been incorporated into your workstation? Be sure you understand how to properly use all of the equipment required to do your job.
Okay, gentlemen, that concludes this morning's review on industrial ergonomics. We'll now go to a question and answer. Anyone have any comments or questions? Okay, let's move on. I am going to pull up a presentation for Rob Coombs. Rob, I can navigate for you, or I can release control to your station. What would you like? Hello, Rob?
Can you hear me now?
There we are.
All right. Yeah, if you will just want to pop through, I've just got a few slides.
Very good, sir. I am going to go ahead. There we go. Okay, we're on your first slide.
Excellent. Thank you. Hello. Good morning, everyone. Today I'm going to talk about the IEEE 1584 draft version. They have released it for review and comment. So this is not an official document that we use now, but I thought it'd be important to go over it with people just so that they could see what was coming down the road as far as arc flash calculations. Next slide, please. So currently we use the IEEE 1584-2002 version. It's the guide for performing arc flash hazard calculations. Prior to this, there had been no official experimentally derived equations. They did have something called the Lee equations, but those were pretty general and would give values that were pretty high compared to what might actually happen. This guide, you can use hand calculations, but pretty much all of the software that everyone uses to calculate arc flash hazards comes out of this specification. Next slide, please. So, like I said, they have a draft version. It's actually the 4th draft version, but they finally are putting it out for people to make comment, and there'll be some changes. So this is not an official IEEE document. So today, if we get a power study, we will still use the 2002 version. But there's going to be some more specific data points when we do these in the future, when this does get released as an official version. I thought I'd cover some of the big ones. Bus configuration is going to be important, whether it's a horizontal or vertical bus. Ways to think about that might be, is it an MCC or is it a load center withdrawal circuit breakers? Medium voltage breaker case, Magnablast versus probably any of your more common breakers these days. They're also going to differentiate between arcs in a box and an air, which they actually do in the 2002 version. But the difference here is they are going to make adjustments based on enclosure size. I don't know how that's going to affect these, but it's a good bet that the arc flash that someone used with the old method compared to this new method will change the incident energy in the arc flash boundary. And I've got a couple of equations here on the next few slides. I'm not going to go through them, but you'll get an idea of how much this will change. Next slide, please. So that very top equation there, that is the existing equation for calculating incident energy. So they had one equation, and you had a couple of variables, no matter the voltage level or arcing current, that's what you used. You can see below that, this is what's going to be coming out in the draft version. They are breaking down further different voltage levels, and a lot of those variables will depend on the orientation of your bus and the size of your enclosure. So you can see that there's a big potential for the incident energy calculation to change. Next slide, please. I think I just have a few more. So this is before was the incident energy. Here's your arc flash boundary. Again, on the left side is the one that we currently use, and that all of those labels you see on your gear are based on. One equation, couple of variables. Now they're going to have multiple equations for different voltage levels, and again, all of those variables on the inside are based on tables, which are based on orientation of your electrodes or your bus, and also enclosure size. So this is just an example of how much potential there is for the calculations and those stickers to change once this becomes an official document. Next slide, please. So, like I said, when it becomes an approved version, then all of the studies will be based off of that. I don't know when the release date is. It's been, what, 16 years since the first one, and this is just recently they released this draft version. So there'll be some changes, but it probably won't be to the equations you saw, because those are based on a bunch of experimental data where they blew up a lot of stuff in different configurations in different boxes. They used statistical method to determine the best fit for the curve. So it'll be interesting to see what happens. One important thing that may come about with this is that when we do have an official version, one, our studies will reflect that, and then two, for everyone out there in the field or talking with customers, and they have studies that have been done and they are older, this is an opportunity to tell them, hey, we have a new standard out there that should be more accurate for your system. How about getting a new study done? And that is all I have. I think my next one just says questions.
Yeah, Robbie, this is Tim. Hey, with regard to your Arc Flash study changes, I guess there's a couple things. A, will sales be briefed on the need to spend more time on site for the purposes of measurements of enclosures? And then secondly, in the event that this is a system that's already been installed in service and we are not going to know the bus orientation and such, and we're not going to be able to access and view how it's oriented, how are you going to approach that?
So yes, there'll be some investigation when it becomes an official standard as far as studies and such, because that will change how we gather data. It's going to be a little bit more detailed. And then two, as far as the orientation, we obviously will do our best. The guide so far has some examples of different type gear and what you may want to use, because it's not as simple as just bus orientation. Sometimes it's bus orientation and situation that the gear is in. Is the breaker in or out? What orientation you want to use? Obviously, we can fall back into apparatus service, what kind of drawings they have, especially for legacy equipment. They may show the interior structure. And then our last fallback that we pretty much have to do on every study is there are certain assumptions. We can make assumptions and then say this is assumed. If it's different and you find out that it needs to be redone, or a lot of our studies, a lot of our software is powerful enough that we can run it in multiple scenarios. And say for some reason we have no idea about orientation of the bus, we could probably run it in 3 or 4 different ones and give them the worst case label until they find out maybe on an outage.
Hey Rob, this is Matt.
Hey Matt.
Hey, I have a couple questions. Can you help us understand why the incident energy and the arc flash boundaries are different or will be different between a vertical bus alignment and a horizontal? What's the key differentiator there that creates that difference?
I do need to read a little bit more about this, but from some of what I have read is how the arc travels and which direction I guess it's going is affected by the vertical or horizontal direction. You can imagine that an arc gets sort of drawn out from the gear, and whether that piece of equipment, whether those electrodes are pointed towards you or pointed down, can make a difference. So, and this is where the IEEE 1584 group, they took electrodes pointed in both directions and blew up a lot of stuff, and they had their devices measuring the incident energy, and they came up with enough of a difference there that they said, okay, we need equations depending on your direction of your electrodes. And then there's even a one point that talks about where your electrodes are pointed and that they have an insulated cover over them, kind of like a molded case circuit breaker. That will affect your incident energy as well. Hopefully that made sense.
Yeah, it does, and I appreciate that explanation. The next question I have is, as far as our using SKM software and such, is that already being geared for this revision? I mean, it sounds like a pretty big revision. The software seems like it's going to have a pretty big change. Is that already in the works, or is this something that we're going to have to take a look at purchasing other software or something, or an update?
Yeah, it is in the works. In fact, the latest version of SKM that was available 3 weeks ago has an option for running it in this draft version. I've read a few pieces. In fact, one of them by the vice chair of the 1584 committee. He says, don't use that yet because this is not an official document, you know. But the software manufacturers, and especially SKM, which we use, yeah, they are all over this, and they can actually run this. We can run this with this draft version right now.
Nice. And the last question I have is there going to be any requirement, either from local or some other AHJ, that will require businesses to update their arc flash coordination based on this new revision?
That is a very good question. I believe that most of them follow the NFPA 70E, and there's, shoot, some of them aren't even up on 2018 yet. They're probably still using 2015. Their requirement usually for changing the arc flash study is I believe it was 5 years to update it or any major changes to the system. It doesn't talk about the way that it's calculated. And in fact, that's an excellent question. I know that NFPA 70E references IEEE 1584, but I don't know if it references the specific 2002 version or most current version. I don't think that they will be required to, but I think this would be a good point still to bring up to some of the more forward-thinking maintenance managers.
Hey, Robbie, this is Timmy again. With regards to the NFPA 70E, I'll get you an answer on the 1584 standard that's referenced in it. I'll get that out. With regards to the arc flash hazard analysis and all the field labeling that's required, just because the labels are older than, let's say, 5 years, please understand that we do not have to replace the labels if at the 5-year point the audits, or before the 5-year point, the audits have been done of the existing arc flash analysis and nothing's changed. Okay, it's more of an audit in an administrative aspect. It's an audit, but it's not required to go back through every 5 years and put new stickers on. Obviously, if they're worn and tattered, yes, we need to replace those stickers. But in general, as Robbie mentioned, it's every 5 years or changes to your distribution system that do impact your fault analysis.
But we should still be asking those questions. If we see a label that's 5, 6, 7, 8 years old, then we should still ask that question if they have a more updated arc flash coordination study and it just hasn't changed, correct?
Yes, and again, they don't have to regenerate the wheel on it, because obviously, if you ask Robbie on the costing aspect, if they can do their own analysis, not analysis, but audit, and say, yep, nothing's changed, and we have maintained our equipment, then it's valid. It's up to us as the technicians coming in to do the service work for them to say, hey, is this up to date? When was the last time you guys audited and reviewed your arc flash hazard analysis?
Great, thank you.
All righty. Any other questions?
If anybody has any questions down the road, something that comes up and you want to know more about the exciting world of arc flash calculations, you can just email me. We do have a copy of the 2002 standard if anyone wants to put themselves to sleep at night. It's on the, I believe it's on the share drive.
Thank you, Rob. And thank you for your contribution, Tim and Matt. So let's move on to roundtable. Are there any open table items that anyone wants to share information, etc.?
Good morning, Ramona. This is Timmy again.
Hi,
Hey,
Timmy.
real quick to the answer with regards to the IEEE standard 1584. It's listed under Annex A. It does reference IEEE standard 1584, Guide for Performing Arc Flash Hazard Calculations, dated 2002. Now, having said that, obviously NFPA 70E will not be revised for another 2.5, 3 years. So obviously that's not going to change. And the incorporation of the change, that would have to be, I'm assuming, presented to the board of that go through and review and approve the changes to NFPA 70E. Okay. Having said that, the next thing I want to bring up is I recently had an opportunity to go conduct training at the Port of Tacoma for a brand new substation that was installed. And the equipment was of the hardened arc flash resistive type of switchgear. Okay, the neat thing about it is that the blast, in the event that it did fault out and blast, it was designed to go up through an exhaust duct and travel horizontally across the top through this exhaust duct and out of the building. And two things that I pointed out to the crews at the facility. Two things. One, even though you do have arc resistive gear and it still it is intended to ideally contain the arc, you still do have risks of injury from it simply because there are seals that may exhaust out at you. And also I mentioned that they needed to make sure they still wore required PPE, daily wear type, and in addition to that, making sure they wore hearing protection. But secondly, the more important comment I had for them was, look at where the exhaust actually exits the building. That area should, for posting purposes, it had a very, very small sign that said, oh, by the way, hot gases could come out of here. And that was it. It was a very, very small sign. Having said that, I made recommendations that the area be properly bounded off during any kind of switching operations, racking and or switching operations to preclude individuals from being in the area in the event of a fault occurring, and more importantly, improving their warning systems that the area still under normal circumstances could be become a danger zone. So it was something that was pointed out and they've taken for action.
Hey, Ramona,
Thank you,
I have a
Tim.
couple of things. So next week we are going to restart NETA at night. We haven't done it for several weeks, and I apologize about that. A lot of people have been busy, no excuses, but we do want to pick that up. We got a lot of great feedback from those that did attend. A meeting invite will be sent out later today to give you guys a heads up, but we do want to start that again, probably the same time, 7 o'clock Wednesday, and we'll take a look at conducting this every other week. So I know a lot of you are gearing up for the NETA 2 exam in July, and we feel that this will be a big heads up on the exam, and also help provide some more information on our day-to-day testing and kind of relate that to theory and everything else to make us better technicians and serve our clients much better. So I'm pretty excited about gearing this back up. Like I said, we got a lot of great feedback, a lot of great participation in the past, and so we want to continue this and carry this forward and maintain a consistent schedule. And again, I apologize for that dropping off of our radar, but we're getting back on track, and I appreciate everybody's patience with that. The other, the last thing I'd like to talk about is today during our safety conversation, we talked about ergonomics. One of the things that we do, and it's required by many of our clients, is a stretch and flex. Those of you that are on longer term projects, I know Joey, you and your team are out in New Mexico, and it's required there. We see this off and on several projects. That is a great thing for us to be doing, and that's something that we're going to be taking a look at, seeing if we can incorporate that as part of our morning tailgate meeting. There's a lot of value to getting us started off and stretching and getting our muscles and stuff prepared for the day's work. I know that you guys that have been out on site, hopefully you guys are seeing value in that. And it takes, relatively no time to do, but the rewards of doing such are immeasurable. So more to come on that, but it's something that we do want to start. If anybody has any input or feedback on things that they've seen on site that has worked for them and they think it's a great idea, please funnel that up through your managers so that we can take a look at that and take the good ideas and try and establish our own stretch and flex program.
Okay, anyone else?
Hey, Ramona, this is Rob.
Yes, sir.
Hey, just wanted to give a shout out to Tim. He passed a couple of big tests here recently. One as a NFPA certified electrical safety compliance professional, and also his NETA 4 exam. So if you see Tim, give him a pat on the back and an attaboy.
Excellent job, Mr. Conley. Okay, gentlemen, if there aren't any other questions, roundtable or just information share, let's move on to roll call.
Oh, hey, Ramona, this is Timmy again.
Yes,
Hey,
sir.
the latest and greatest NETA World magazine is out. We got a case of them up here. It's the summer 2018. I'm not sure how NETA does the distribution on these, whether each office gets a box of them or not. Let me know. I do have a whole lot of extras here.
I haven't received anything.
I should have received that electronically, and if you'd rather have that electronic and you didn't get that in your inbox earlier this week, let us know and we can send that out to everybody. Whether you want a hard copy or the soft copy, just let us know if you haven't gotten that already.
All right, gentlemen. So at this point, we're going to go to roll call. Ryan Herbst, if you will please email me your attendance sheet. And Joe Selden, if you will please do the same for Sumner. Sales and field services, if you please. I am going to go down the roll call now. Joey Ashuto.
Good morning, Ramona.
Good morning. Bruce Archer. Souther Board.
Southerboard's here.
Thank you, sir. Nick Botkin. Jason Bontrager. Patrick Barnhoff.
Here.
Thank you, sir. Jim Botzer. Jason Carlson. Thank you. Adam Carter. He is on job. Darren Churchill.
Good morning, Ramona.
Good morning, sir. Go back. There we go. And Zach Cleary. John Conley. Tim Conley, I have you. Rob Coombs, I have you, and thank you for your presentation today, sir. Derek Dustrom.
Hey, I'm here.
Good morning, sir. Anthony Diaz.
I'm here, Ramona.
Good morning, sir. And here we go. Mike Kelly.
Yep, I'm here.
Good morning, sir. Chris Kirschner. Good morning.
Chris is here, and Jason was on, but he had to step off to the airport.
Okay, I will go ahead and I will note that. Thank you. Toby King.
Good morning.
Good morning, sir. Tim Klosterman.
Here, Ramona.
Morning, sir. Dave Marin.
Good morning, Ramona.
Good morning, Dave. Good morning. Darren Miner.
Morning, Ramona.
Good morning, sir. John Moore. Mark Nelson.
I'm present here. Thank you.
Good morning, sir. Chris Parrish. And Charlie Ray.
Good morning, Ramona. I'm here with Wally, too.
Great. I have Wally as well. Thank you. Jermaine Sutton.
Morning, Ramona.
Good morning, sir. And Matt Thomas.
I'm here, Ramona.
Good morning. And Salman. Matt Wallace, I have you. Thank you, sir. Joel Wilbur.
Morning.
Good morning. How's that sunshine?
Oh, the drive's lovely.
All right. Did I miss anyone? All right. Thank you so much for your attendance today. I have to say one thing. I'm so happy we're back on GoToMeeting. Yay, yay, yay. Thank you. Appreciate your presentation today, Rob. Everyone who contributed, have a good week. We'll see you next week.